The next talk we have is on an extension of our Advanced Interrupt Architecture for real-time. And it's a pleasure to see that being presented by Synopsys, given that we had originally designed AIA to solve a number of challenges for our hypervisor and virtualization. So having this extension for real-time is a logical evolution of what we had initially designed AIA for, and that is showing how RISC-V in general evolves. So,
Is this USB? Oh. Yep. Okay.
Okay, I guess we can start. Hello, everyone, and thank you for joining this session. I'm Evgenii Paltsev. I'm a senior staff engineer from Synopsys company, and I would like to talk about real-time interrupt architecture for RISC-V. There are automotive and embedded markets where customer asks for real-time capable solutions with RISC-V. And one part which is not real-time capable now is interrupt architecture. So, we have several requirements for interrupt architecture. First of all, we need real-time interrupt itself, deterministic low latency interrupt. We want to have multi-core and virtualization support, as well as features like interprocessor interrupts and flexible interrupt routing. On the other hand, we also want to support resource-constrained system like busless single-core system. It should be compliant to RISC-V FISA, including H extension if we are talking about virtualization. And on top of all, we want to have a single solution with unified programming model, because we don't want to have completely different and incompatible implementations for single-core, multi-core, system with virtualization, you name it. Most of these requirements are already covered by RISC-V Advanced Interrupt Architecture. And we absolutely want to use it instead of creating something custom and incompatible from scratch. For the missing parts, Advanced Interrupt Architecture can be extended with nested vectored interrupts, low latency interrupt delivery, and lightweight real-time interrupt architecture. First part of proposed extension is hardware trap stack pointer management. In general case, we start trap handler without valid stack pointer, because we may get from trap from different privilege levels, and our stack pointer may point to some memory which we don't even have access to. So we have firstly check if we need to recover a stack pointer for current privilege level, and to perform this recover. And it needs to be done without overriding context in GP registers, because we cannot save on stack, because we don't have stack right now. The goal here is to avoid this stackless execution in trap handler, which can be done by swapping stack pointer by hardware on trap entry and return from trap. It reduces context save and restore ahead, and if needed, it allows to automate trap frame by hardware. Trap stack pointer management is runtime configurable, for which privilege level which is capable to getting interrupts. And it's compatible with all already existing interrupt handling modes, which are direct and vectored. Okay, next to the second part, which is nested vectored interrupts. We need to have interrupt nesting to achieve latency predictable interrupts. And we need vectored interrupts to, so prologue and epilogue of interrupt can be optimized for each vector to achieve low latency. We added new interrupt handling mode, which is nested vectored interrupt handling mode. We added to tvec CSR, and it can be individually configured in runtime for each interrupt capable level. So how do we implement it? We have multi-level interrupt hierarchy with major local interrupts and external interrupts. So we need somehow to align them. And we can do it by reporting major interrupts via IMSIG file. It's shown here. Advanced interrupt architecture already defines configurable interrupt priorities for major interrupts via IPO-array. So we just use them as external interrupt identity when reporting to IMSIG, again here. And that simplifies things a lot. We have a single place for interrupt arbitration, which is IMSIG. We can control interrupt priority threshold for all the interrupts via existing EI threshold CSR. And now we have external interrupt identity for all interrupts. So we can easily construct a vector table. Basically, we just do it for external interrupts. Here on the slide is shown vector table layout. First vector is a shared vector for exception traps. After that, we have 255 individual vectors for high priority interrupts with external interrupt identity from 1 to 154. And the rest of interrupts which have lower priority, for them there is a single shared vector in the end of the table. Interrupt claim is now done automatically by hardware on job to interrupt vector. And at the same time, hardware also updates interrupt priority threshold. So after we jump to vector, all interrupts with same or lower priority are turned off. And so interrupt nesting now it's trivial. When we jumped to interrupt handler, we just need to save critical trap context, and we can enable interrupts. After that, we can get new interrupt with high priority if it's pending. When interrupt is processed, software triggers interrupt threshold update to previous value. And what's good here, we don't add any new CSR. We just used everything which is already existed. Now, to real-time interrupt delivery. MSI delivery, or message signal interrupt delivery, is not deterministic in general. So we add new optional delivery mode, direct MSI. It provides deterministic low latency DMSI bus for interrupt delivery. This new delivery mode doesn't replace classic MSI delivery, but coexist with it. We still have regular bus for all memory operations, which can be used still for MSI, but we have DMSI bus as well. And it's configurable for each interrupt source at the click site. And again, we don't add any new CSRs here, which is good, and new delivery mode is transparent for software. Now, let's talk about a resource-constrained single-core configuration. In such system, we may not even have a bus to deliver MSIs from applic to MSIG. But actually, we don't even need applic here. Instead, we can just connect the interrupts via client, as we already done previously. So we get nested vectored interrupt handling mode without MSI and without applic. But if nested vectored mode is not required here, even more components can be removed. For example, a priori with configurable interrupt priorities can be removed. EI threshold with hardware threshold stack can be removed. We can use instead of vector table, we can use a single trap vector as it's used like in direct mode. So we can create a significantly smaller solution. So about latency and area impact. We've achieved deterministic low latency interrupt delivery. We have low software overhead for interrupt prologue and epilogue. For example, decrease interrupt prologue instruction count is minimum 5 times compared to direct interrupt handling mode. And this extension doesn't result in significant overhead in hardware, which is nice. About current development status. We have Synopsys real-time interrupt architecture specification completed. We have functional simulator, instruction and cycle accurate simulator. We have functional tests and compiler support. We have Synopsys RISC-V Remix core, which has machine, supervisor, and user modes. And we have a lot of things which are now in progress. First of all, it's Synopsys RISC-V RTIA core, which includes hypervisor extension. And also it's virtualization software prototype and various open source software porting. And we are planning to make a real-time interrupt architecture specification proposal to RISC-V. Thank you again for joining this session, and if you have any questions, go on.
Looks like we don't
Hello,
have
hi, there is a question. My question is, so you are targeting this also for the RVM profile for the microcontrollers, or this is something that is above the AIA for application processors only?
So this is extension to RISC-V Advanced Interrupt Architecture, and because it doesn't change a lot and it doesn't add a lot of it doesn't require a lot of things, new things to be made in hardware. It can be still used for even for big system because it doesn't it won't result like in significant increase of like gate count. But mostly these things are interested for indeed embedded, something embedded, something automotive, and these parts. But still, it's supported. This solution will support this virtualization. So.
Yes. Is there any relationship between your work and the one that is done in the Fast Interrupt Working Group? And if not, is there any plan to merge your contributions?
Yeah, it's a good question, and it's indeed one of the reasons why we are here, because we want to discuss it with people from Fast Interrupts group. We eventually want to have some solution to reach a ratified state. We are proposing this solution because it already covers some topics like multi-core support and virtualization, which are not yet implemented in case of Fast Interrupts, in case of Clint. And because we don't add a lot of stuff comparing to Advanced Interrupt Architecture, and it's basically just some extension of Advanced Interrupt Architecture. we will see some advantages in this implementation. But indeed, we want to discuss it with fast interrupt group and see how we can better proceed with it.
Hello. I'm not sure if I'm missing anything, but how is this real-time interrupt extension related to hypervisor extension in terms of hardware design or software part?
First of all, we just adding this same interrupt handling modes to all privilege levels, not only like to machine or supervisor, but also for VS levels as well. And first of all, because of that, same software can be used in S mode and in VS mode. In terms of real time, it could be a bit tricky because obviously if we just expect what multiple guests would be will be same reactive as just one software running in S mode, it's cannot be true. But if we proper design our software, it still can be beneficial for guests as well, because we might have one guest dedicated for interrupt handling and lots of other things which can be benefit from this solution. But it still can coexist with regular software which doesn't use these new interrupt handling modes.
Thank you.
Thank you.